Greetings to all of you. The session we are going to cover with the intermediate chemistry will be very much fetching for your international entrance and competitive exams as well. India is conducting JEE Advanced, JEE Mains content, JEE Mains admission examinations towards IIT and NIT stream. That will be our technical domain to take the admission all across India. NEET medical chemistry, medical entrance exam will be there. That are also applicable all across the India. Those who are seeking admission over there can be placed anywhere around India. And Telangana and Andhra Pradesh government are conducting MCET examination for the BTech entrance. BTech admissions will be purely relying on this MCET entrance examination will be conducted. And in addition to that, when government is organizing so many job opportunities by government job notifications that are called competitive exams, where different domain subjects will be assigned among one common content will be there called general studies. In that, general science question paper will be there. In all these domains, you can go for the basic fundamentals of chemistry, and that are provided over here. Whatever content we are discussing, all these entrance exams or else any kind of competitive exam you're aspiring for, everywhere the session will be very much fetching for your serious preparation. So that let's enter into our today's session. Explain the isomerism of coordination complexes as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry, where the complexes are provided to be assigned what kind of isomerism you can notice. If you see the complex, this is zinc, and that is in contact with the amino ligands. 4 amino ligands are present around the zinc sphere of coordination. Zinc coordination sphere, you can find the amine ligands. But if you go with copper, you can notice 4 chloro ligands are present in its coordination sphere. So these two complex are existing together. Such complex is said to be double coordination complex, where you can find 2 central metals around ligands are present in their particular sphere. And if you are going to change this kind of system, the environment is slightly modified, where zinc is replaced with copper and copper is now exchanged with zinc. This is the kind of replacement process of metals. One of the coordination sphere metal exchanged with another coordination sphere metal. If this is the case, what kind of isomerism you can say as per the IUPAC? IUPAC is the International Union for Pure and Applied Chemistry. According to that, it might be ionization isomerism, coordination isomerism, linkage isomerism, geometrical. The expected answer is coordination isomerism. Let's see how can we go for the coordination isomerism for this kind of exchange of metals among this double coordination complex formation. Let's see about that. Coordination isomerism occurs in the compound when complex anionic and cationic. Here, this is the zinc complex, which is said to be cationic with respect to copper. And the entire copper complex is the anionic part of zinc coordination complex. This is the way here two kind of coordination spheres are coexisted. Right. So they are participating in the interchange of some ligands from the cation to the anion. Here, amino ligands are exchanged with chloro and vice versa. Chloro with ammonia will be exchanged. Whenever ligands are exchanged, so that coordination sphere entirely modified. Hence, there are two complex compounds bound together, one with the negative charge and another with the positive charge. In a coordination isomerism, anion and cation complexes of coordination compound exchange one or more ligands. So whenever zinc tetramine is there, that used to exchange the amino ligand with the chloro, so that you can experience initially zinc surrounded with amine and here zinc surrounded with chloro, so that exchange of ligands you can notice. Copper tetramine zinc Cl2 compounds are coordination. It is the part of coordination isomerism, where coordination sphere got replaced. Coordination sphere got exchanged. So that coordination isomerism is observed over here. This is the way we can answer the question. Question number 1, correct answer will be option number B. Move on to question number 2. A colored crystal of cobalt 2 chloride is placed at the bottom of beaker containing water. Color spreads throughout the water over time. Figure 3.1 shows the spread of color after 2 days. So here, a pinch of color was inserted, which is made up of cobalt 2 chloride, which is a blue in color. Whenever blue colored substance is placed in the water, after 2 hours, slightly that compound is moving and mixing with water, and after 2 days if you observe, entire whatever tiny particle we inserted, that totally mixed up with water. After 2 days, complete miscibility you can observe, right? So this is the way the reaction got carried. So that the question is, what kind of change you can notice whenever these crystals of cobalt chloride inserted into water in such a way. After 2 days you can notice miscibility of cobalt chloride with water. So that what chemical changes you can notice. In order to explain, we have the chemical equation over here. Whenever cobalt chloride -2, that is regarded as a cobalt plus 2 complex. Cobalt plus 2 chloride, Roman numeral 2 indicates the oxidation state around the central metal, right? So that is the case. Cobalt chloride -2 in contact with water, so that tetrahedral complex now transformed into, upgraded into octahedral complex, so that 6 water molecules surrounding, and this is the kind of ligand, chloride ligands are coming. Water molecules are occupying in the sphere of cobalt in this manner. This is the way chemical transformation you can notice whenever cobalt 2 chloride is inserted into water. After 2 days, it is becoming aquated complex. Cobalt aqua complex will be formed over. So this will be the correct representation of chemical transformation. So this is the question collected from Cambridge Assessment International Education. And for question number 2, the correct answer is cobalt 2 chloride now transformed into cobalt hexaaqua cation, right? Now, move on to question number 3, where it is collected from JEE Advanced 2017 question paper, paper 1 question it will be. And these many organic compounds and ions are provided that may be cation or anion, can be taken 1, 2, 3, 4, 5, 6, 7, 8, 9. Among 9 organic compounds, we have to identify how many are aromatic in nature. Aromaticity plays a vital role in organic chemistry. Organic molecules, if aromatic, they are exhibiting exceptional stability over the time, and the nature aromaticity will implicate so many characteristic reactions to the given molecules. Instead of normal regular reactions, they will go for a specific and selective reactions whenever the compound is aromatic. So this is the way aromaticity is the most important phenomenon in organic chemistry pattern. Right. If you go with these many compounds regarding organic chemistry, how many are identified to be aromatic in nature? The expected answer is 5. Let's see how can we calculate. Before going to discuss about aromatic compounds, counting number of aromatics, first of all, we have to think about what conditions, what characteristics should be present in the compound in order to make it aromatic in nature, right? The first nature is it must be cyclic. Whenever compound is a completely ringed one, ring type of structure, then only that is assigned with the aromaticity. That is the fundamental thing. If any opening region is present, a cyclic compounds are not yet all regarded as aromatic in nature. So that any cyclic compound, simply we can say benzene is the best example for aromatic compound. Right. And the second parameter is whenever the compound, cyclic compound which accompanied with the conjugated pi electrons of 2, 6, 10, 14, 18. This is the one in accordance with the 4n plus 2 pi electron system. 4n plus 2 is accorded with the Huckel rule. If any compound is obeying the Huckel rule, then only we can say that compound is aromatic in nature. According to 4n plus 2 pi electron system Huckel rule, the compound must contain conjugated since any compound is having alternative double bond arrangement is said to be a conjugated one, and 2 electrons are 6 electrons, 10 electrons, 14 and 18. It may be a kind of any these numbers, then only we can say they are obeying Huckel rule and they are the part of aromaticity. This is another one. According to this concept, we can go for the counting of pi electrons and assigning aromaticity to the compounds. If you go with the compound, you can notice that it is the cyclic one, so that first criteria got satisfied. And if you observe this compound, you can notice 2 pi electrons over here, and 2 pi electrons if present, that is a part of 4n plus 2 pi electron system. Hence, you can say it is aromatic. Put a tick mark over here. Go with the compound of 4-membered ring. 4-membered ring is in a conjugated system only, but two double bonds are located, and those two double bonds accounts for 4 pi electrons only. But 4 pi electrons not the matter of aromaticity as per the Huckel rule 4n plus 2 formula, so that you can cancel out. It have only 4 pi electrons, so that you can cancel out. Go with benzene. Benzene is the cyclic, so that first criteria satisfied. Second, alternative arrangement, all the double bonds are double singly occupied alternatively, so that the second criteria satisfied. Third is 6 pi electrons, 4n plus. If 6 pi electrons, that obviously going through the 4n plus 2 system, and Huckel rule is applicable. So all criteria got satisfied in the compound, so that you can say it is aromatic. Put a tick mark. Move on to another compound having 4 pi bonds and 8 pi electrons in that. 8 electrons not the part of that aromaticity, so that cancel out. And move on to another where you can notice fused one. It is a bicyclic ring system where 7-membered and 5-membered are togetherly fused, and all pi bonds are said to be in conjugation. You can count 1 2 3 4 5. 5 2s are 10. 10 pi electron system is the part of 4n plus 2, and a Huckel rule. Conjugation is there, cyclic nature is there, sp2 hybridization is there. All are satisfying, so that put a tick mark over here. 10 pi electrons are the part of 4n plus 2 system. Huckel rule got occupied or satisfied. And one more condition over here, presence of conjugation. Just now we said, if you observe here, all the pi bonds are in continuous sphere. Continuous double single bond spheres are located, which is called alternative arrangement called conjugation. But if you have this kind of arrangement where double bonds are there, and this double bond is also there, but here double bond chain got broken. If this is the case, and this is the carbon is accompanied with sp3 hybridization. One more compulsory condition for the aromaticity is all the carbons must satisfy sp2 hybridization. No carbon will be sp3. If sp3 carbon is there, you can cancel out aromaticity. So that this compound is accompanied with the sigma bond. So two sigma bonds are cumulative. So consecutive sigma bonds are present, so that you can't think it is an alternative system. It is the kind of a cumulated system, so that you can cancel out its aromaticity. But here the compound is aromatic in nature. These are conditions. These are the conditions. And one more point is noticed over here. It must be flat. Any compound taken over here, if you are taking the compound onto your palm, the entire surface should be laying on your palm, then only you can say that is the flat molecule. That means planarity. Being sp2 carbon compounds are planar in nature, all are flat in nature, so that it should obey planarity. One is cyclic nature, second is alternative arrangement, alternative conjugation must be present. In either 2 pi electrons, 6 pi electrons, 10 pi electrons, 14 pi electrons, 18 pi electrons, 4n plus 2, Huckel rule should be obeyed. Another condition is planarity must be satisfied by the given compound, organic compound, then only you can say it is aromatic. Always in the case, first three conditions are aromaticity are satisfied. So all sp2 carbons, if present, then only the compound is said to be planar, and planar compound move on to this aromaticity. These are the requirements of aromaticity. In accordance with these selection rules, we will screen out all the compounds one by one. Move on to compound number 1, where you can notice 1, 2, 3, 4, and 8 carbon chain. And being it is cyclic one, cycloocta tetraene, we can notice this is the IUPAC name of the compound. In accordance with the aromaticity criteria, cyclic, that is obeyed. 8 pi electrons. If you count the electrons, 2 plus 2, 4 plus 2, 6 plus 2, 8 electrons are there. 8 electrons not satisfying 4 and plus 2 pi electron system. So 8 electrons not part of, 8 electrons not at all noticed, so that you can cancel out at this instance only. So 8 electrons is present, 4n plus 2 is not obeyed. If 4n plus 2 is not obeyed, it is non-aromatic in nature. So you can cancel out this. Move on to compound 2, where you can notice a 3-membered ring, so that cyclic system will be there. And the compound IUPAC nomenclature is cyclopropenyl anion. Being it is a negative charge, you can put over anion here. Cyclopropenyl anion is the compound where cyclic, so aromaticity cyclic one of the condition got satisfied, and being 4 electron system, 4 pi electrons is present, 4 pi electrons not the part of 4n plus 2 rule, so that you can cancel out at this instance. 4n plus 2, 4 pi electrons not required, so that 4n plus 2 electron system not obeyed, non-aromatic we can say. Move on to another where 3-membered ring is there, where 2 electrons only present, being positive charge, no electrons. Positive charge means vacant, absence of electrons, no. So that only 2 pi electrons, 2 pi electron system is the part of 4n plus 2 system. Hence you can say aromatic. What is the IUPAC name of the compound? Cyclopropenyl cation. Let me repeat, cyclopropenyl cation is the name. It's a cyclic 2 pi electron, 4n plus 2 obeyed by the compound. Hence you can say aromatic in nature. Move on to cyclohexadiene. A 6-membered ring with the 2 pi bonds which are in conjugation, but these 2 carbons are said to be sp3 sp3. Planarity lost. The compound is non-planar in nature, and moreover only 4 pi electrons are there. 2 conditions required are exempted, so that you can cancel out this compound as well, so that non-aromatic in nature. Move on to another compound. This is said to be cyclohexatrinyl cation. Cyclohepta, sorry, not hexa, being 7 carbon ring it will be, so that we can say cyclohepta. Trinyl, 3 pi bonds are present, so that trinyl, and here you can notice a cation, positive charge, so that a cyclohepta trinyl cation. Its simplified name is a tropylium cation. Can you find cyclic nature? Yes, it is a cyclic compound. 6 pi electrons. So can you notice 3 pi bonds indicate 6 pi electrons only. And 4n plus 2 system got completely satisfied. 6 pi electron is the part of 4n plus 2, right? So that aromatic in nature. One more condition, planarity. All double bonded carbons are sp2 obviously, and moreover this cation, any cation is accompanied by the carbon of sp2 hybridization only, so that entire molecule is said to be planar. So tropylium cation is the part of aromatic nature. Move on to another 5-membered ring system with the 2 pi bonds and a cationic at this one edge. So it is said to be a cyclopentadienyl cation. How many enes are there? 2 enes are there, 2 double bonds are there, so that I may mention dienyl. And here the positive charge is indicated with the cation. Being it is a 5 carbon ring system, you can say cyclopenta. Cyclopentadienyl cation is the IUPAC name of the compound. If you see, it is a ring annular system, so that let me mention cyclic one, and only 2 pi bonds, so that it will be accompanied with the 4 pi electron system. Only 4 pi electrons are there, so that it is not the part of 4n plus 2 Huckel rule. Hence it is non-aromatic in nature. Move on to another compound where a cyclopentadienyl anion. You change the charge over here. Whenever negative charge indicated, it also the part of this ring system, so that you can count to 2 plus 2 plus 2. 6 pi electron system, it will be 4 plus 2 by the compound, and it is the part of aromatic nature, so that this cyclopentadienyl anion is an aromatic compound, and a planarity is perfectly balanced over. And this is the compound. You can notice benzene ring. Wherever benzene is there, you can blindly say it is aromatic compound, so that you can go with aromaticity. And this is the compound called as a phenanthrene. Phenanthrene is annular. Annular means what? Ring system. And you can notice all the rings are in the not straightforward. If all the rings are in straightforward, we can say anthracene. If it is some angular representation is there, this is said to be a phenanthrene. Anthracene, phenanthrene, both are the kind of positional isomers only. Ring fusion positions got somewhat changed. If all 3 rings are in the straight position, we can say anthracene. One of the ring got occupied in the somewhat angular form. It used to give this some angle over here. That is said to be a phenanthrene. Can you find cyclic nature over there? Yes, it is. And can you count 1, 2, 3, 4, 5, 6, 7 pi bonds alternatively arranged, one after another, one double single bond, double single bond alternatively arranged, so that a 7 pi bond accounted for 14 pi electron system, and 100% 4n plus 2 electron system is obeyed, and you can say it is aromatic in nature. This is the way cyclopropynyl cation, cycloheptatrinyl cation, cyclopentadienyl anion. This is said to be dihydronaphthalene. This is said to be phenanthrene. These many molecules are the part of aromatics, so that you can count why aromatic compounds are located in this given bunch of molecules. Uh, there is another question number 4, which is collected from JEE Advanced 2017 question paper 1 question. It is the conductance of 0.0015 molar aqueous solution of weak monobasic acid was determined by using conductivity cell consisting platinized platinum electrodes. The distance between the electrodes 120 centimeters with the area of cross section 1 centimeter square. The conductance of this solution was found to be 5 into 10 to the power negative 17 Siemens. The pH of the solution is 4 only. The value of limiting molar conductivity of this weak monobasic acid in an aqueous solution, Z into 10 to the power 2 Siemens centimeter inverse mole inverse. The value of Z is expected to be 6. How can we calculate? Let's see. Here the formula for specific conductance K is equal to G into L by A. Here specific conductance is equal to G value is given as 5 into 10 to the power negative 7. 5 into 10 to the power negative 7, that is the conductance value. Okay. And length is given as 120 centimeters. 120 centimeters distance of electrodes was mentioned, and 1 centimeter apart. So distance between the area of cross section is given by 1 centimeter square. 120 centimeter distance is there, and area of cross section is mentioned as 1 centimeter square. If you cancel centimeter, but one more centimeter is there at the denominator, so that it will become a centimeter inverse. So 5 into 10 to the power 7 into 120. What you can do? 5 12s are 60, so that you can cancel out that, and moreover there's a 10 to the power minus 7. Here 10 to the power minus 7 is there. You can cancel out 1 0 with the 1 0 over here, and one more 60 is having one more 0. That 0 is also cancelled with another negative 0, and leftover will be 6 into 10 to the power negative 5. And this is called what? Specific conductance. If you know the specific conductance, it is obvious to go for the calculation of molar conductance. So molar conductance is given by this lambda m for molar conductance, K into 1000 by C. K denotes what? Specific conductance. 1000 is the numeral, and C is the conductivity, right? So K value just now you just calculated, that is 6 into 10 to the power negative 5, and this 1000 remains as such, and C is given as 0.0015. So C is given as 0.00. C denotes what? Concentration. Here G is the conductance, C is the concentration. What concentration they mentioned? Concentration is conductance of 0.0015 molar aqueous solution. This molar concentration is the C value, that is 0.0015, which is given within the problem itself. First of all, we have to calculate specific conductance. Substitute the specific conductance value in the equivalent molar conductance. Molar conductance formula is lambda m is equal to K into 1000 by C. K denotes specific conductance. Just calculate 6 into 10 to the power minus 5. 1000 can be taken as such. C for concentration, that is 0.0015. Then within the problem they mentioned pH conditions are mentioned as pH condition of the solution is taken as 4. So if pH is equal to 4, pH is nothing but negative log of H plus ion concentration, no? So that pH is equal to 4 can be written as H plus concentration is equal to 10 power negative 4. 10 power negative 4, if you are writing, that is equal to C alpha. C alpha is equal to degree of ionization, right? So alpha, if you want to calculate alpha, what it will be? 10 to the power negative 4 is equal to C alpha. C for concentration, alpha for degree of ionization. You are supposed to calculate a degree of ionization, so that alpha is equal to 10 to the power negative 4 by concentration. C for concentration can be taken. That concentration is 0.0015. So 10 to the power negative 4 by 0.0015 can be taken. This is the ratio. Alpha is equal to, we have another formula, molar conductance at the definite concentration by molar conductance at infinite concentration. So alpha is taken by the ratio of molar conductivity. Molar conductance at a definite concentration by molar conductance at infinite concentration, that can be taken over. So that alpha value is known to you, that is 10 to the power negative 4 by 0.0015, and lambda m value. So molar conductance is given by 6 into 10 to the power negative 5 into 1000 by 0.0015. And you don't know about lambda m, so as such if we kept over here, all the remaining terms are known to you, only this is the one unknown, that is lambda m not standard. So that can be calculated after putting over like this. Left side you can find 0.0015, right side also you can find 0.0015. You can cancel out them, and here you can find 10 to the power negative 4. Here you can find 1000. Sorry, not that one. Here you can 10 to the power negative 4 is there, 10 to the power negative 5 is there. 10 to the power negative 4, 10 to the power negative 4 got cancelled. 10 to the power minus 1 will be there. Minus 1 and 1 0 you can cancel out, so that leftover will be 100 only. So the entire value remains is 6 into 10 to the power 2. That is the value you got for lambda m, right? Molar conductance at definite volume, at an infinite concentration. So that is calculated as Z is equal to R, because 10 to the power 2 is already given. 10 to the power 2 term is already there, only required to be calculated, that Z value is calculated. Okay, so limiting value, after the limiting value, this not lambda m naught can be taken. So 10 to the power 2, which is already given, only the term we need to identify, that is 6. For question number 4, 6 is the correct answer. This is the question related with electrochemistry. Move on to question number 5. Question number 5 related with the analytical chemistry. The number of significant figures in 2.0400 is 2.0400. If this is the numeral, in the significant figures to be identified, the reachable answer is 5. You can cancel out remaining all. For question number 5, answer is 5. We have to go for how to solve this one. In order to calculate that one, all non-zero digits are significant. Non-zero digits are 2 and 4. So that we got only 2 first. 2, 4 are now non-zero digits are 2. 2 is non-zero and 4 is also non-zero now. Move on to another condition for significant figures. All zeros that occurs in between any two non-zero digits are significant. If you take 2 and 4, in between this 0 is there. Any non-zero digits in between number will be significant in nature, so that the in between 0 will become significant figure. So that in between non-zero units, the 0 or the zeros are significant. So that we got 3 significant figures over. Move on to another point here. All zeros that are on the right and last non-zero digits after the decimal point are significant. Okay. All the zeros right hand side after non-zero and decimal point are significant in nature. Right hand side, your right hand side you have to go for the consideration. This is the right hand side. After decimal, after non-zero, whichever zeros are present, which are significant only, so that you can go for 1, 2, 3, 4, 5 significant figures are there. No, nothing is wasted over. So all the non-zeros are significant. It is very clear. That is point number 1. And in between the non-zeros, if any zeros are present, that also becomes significant. And if zeros are present right hand side, just followed by non-zero, and after the decimal point, all are satisfied for these two zeros, so that you can say these two also these two also significant figures. So 1, 2, 3, 4, 5, all five are said to be significant figures in accordance with the rules whichever assigned over here. By this we can go for the calculation of significant figures for the given compound, and this is the kind of precision and error analytical methods in that we will go for significant figures. Significant figures plays a vital role over there. So precision and accuracy, that kind of terminology is also the part of that analytical part. The correct order of Lewis acidic character of boron trihalides. If boron trihalides are taken into the consideration, boron triiodide, boron tribromide, boron trichloride, boron trifluoride are present, there will be a decreasing order of the Lewis acidic character is mentioned. Lewis acid means what? So any compound is said to be Lewis acid whenever it contains a tendency to accept the electron pair. Electron pair accepting substance is said to be Lewis acid in nature. If you go with BF3 molecule, this may not be correct answer. BI3, BBr3, BF3, BCl3. The order got changed. Either fluorochlorobromo iodo will be there, or else iodo bromo chloro fluoro will be there. These two are the possibilities, and the remaining are not in the correct sequence first, so that you can cancel out option 1 and option 2 first only, because the fluoro followed by chloro followed by iodo and bromo, this is not in the serial order, this is also not in the serial order, so that blindly you can cancel out them. Either the possibility of fluoro to iodo or else iodo to fluoro. Two things you have to reveal out. In order to get the right order among these two, the correct explanation will be Bi3 is more acidic in nature. The acceptor orbital, MTP orbital, and the boron is involved greater extent in N bonding in BF3 molecule. In BF3 molecule, the vacant orbital is not free. Rather, it is participating in the back bonding. Fluorine is having high tendency to participate in the back bonding with the boron, so that vacant orbital is not free, that vacant orbital is not susceptible to accept the electron more strongly. If the orbital is not susceptible to accept the electron, that is not said to be a strong acid. Acid is the compound where the tendency to accept the electron pair should be larger. That is accorded for Bi3 molecule, because it is having natural tendency to exhibit the vacant orbital over. That vacant orbital is having more rapid acceptance of electrons from the Lewis bases, so that Bi3 is more basic in nature, and next level BBr3 will be there, next BCl3 will be there. BF3 is having least Lewis acidic nature because of back bonding. So here some of the electrons from the fluorine will be released into boron, that used to cancel out the negative deficiency of the boron, so that there is no susceptibility to accept the electron pair. This is the way we can go for the comparison of acidic nature in accordance with their availability of vacant orbital to accept the electron pair. By this we entirely gone through the various dimensions of chemistry and various sections covered over: theoretical part, mechanism part, IUPAC nomenclature, problematic section, and physical chemistry. Various domains got covered over, and the session is really informative towards your serious preparation for entrance and competitive exams as well. Hence, I'm sincerely request to like the channel, comment, and share with the aspirants. And in order to comment, we have a question for the session. There is a question for the session from this entire series. If you go for the Lewis acid, Lewis basic nature, in order to define Lewis, what is Lewis acid, Lewis basic, can you give the one line definition for Lewis acid, one line definition for Lewis base? Only I'm expecting about the definition for Lewis acidic nature, Lewis basic nature, right? So that definition you can comment over and share with aspirants. Subscribe the channel to receive more updates. Thank you for watching, and we will go for more new content in the near future. Thank you very much.